Before we begin this month's program, here's a preview of what you'll see in this month's tech news. This month's lead article is an update of the Chrysler Apprenticeship Program. In addition to the CAP update, there's training-related news as well as a list of previous Mastertech releases related to this month's topic. Plus, there's the usual update of what's been released in the area of diagnostic and service software. And since this month's subject is the new 2002 1500 Series Ram, there's a brief look at some Ram pickup history. Some of you may recall the last time a redesigned Dodge Ram pickup was introduced. The bold new styling of the 1994 Ram resulted in a surge in Dodge's popularity among truck buyers. It's hard to believe it's been 8 years since that new Ram debuted, and that it's now time to introduce the next generation Ram pickup. As you can see, the new Ram pickup has a different look. And to go along with that new look, the 2002 Ram has many new components and features. In this Mastertech program, we'll explore those features and components system by system. Along the way, you may notice that some of the items we cover will probably seem familiar to you. That's because these items, while new to the Ram pickup, are actually similar to those you've seen on other vehicles. Oh, and one more thing. The focus of this program is on the new 1500 Series Ram pickup, which is referred to by the letter designation DR. The BR, BE 2500 and 3500 Series Ram pickups will continue with the previous design until the launch of redesigned versions at a later date. Two of the three engines used on the new 1500 Series Ram are new to full-size pickups. Available engines include the 3.7-liter single overhead cam V6, the 4.7-liter single overhead cam V8, and the 5.9-liter overhead valve V8. The 3.7-liter V6 was recently introduced on the Jeep Liberty and was featured in last month's Mastertech. The 4.7-liter V8 has been in use on Dodge Dakota and Durango and Jeep Grand Cherokee. The September 1998 Mastertech covered this engine in detail, and last month's program also reviewed some features of this engine, though the main focus was on the high-output version of the 4.7-liter used in Grand Cherokee. You are probably well acquainted with the 5.9-liter V8 engine. It's been used on a variety of Dodge trucks in the past. Now, even though you may be familiar with these engines from other applications, there are still many engine-related and underhood features that are new to the 1500 series that you need to know about. First of all, depending on operating conditions, the preferred oil viscosity for the 3.7-liter and 4.7-liter engines may be different than what you've used in the past, so be sure to refer to the service information. A look at the coolant reserve overflow tank reveals an obvious difference in the new Ram truck, a new coolant, referred to as Hybrid Organic Additive Technology, or HOAT coolant. The original fill of HOAT coolant provides 5-year, 100,000-mile protection. Keep in mind that when topping off the cooling system, you must use the same type of coolant to maintain this protection. Some cooling system features depend on engine application. 3.7 and 4.7-liter engines use a pressurized overflow tank and inlet side thermostat. The cooling system on 5.9-liter engines is similar to one used previously on Ram pickups. Notice that on all trucks, the radiator and condenser are now side by side instead of in tandem. The transmission fluid coolers are now oil to air and are no longer in the radiator. We'll discuss the coolers and their lines in greater detail later on. While the radiator still uses the engine-driven fan for cooling, the condenser now uses an electric fan that is controlled by the PCM. Another new feature that you may notice under the hood includes a new generator rated at 136 amps. Engine compartment wiring has also changed. For example, the engine wiring is now routed to reduce radio and electromagnetic interference. Some of the changes you may encounter are not so obvious. For example, those that involve control of the fuel, ignition, and emissions systems. 2 PCM inputs are worth special mention here. The 3.7-liter engine is equipped with dual NOx sensors. You've heard us mention these NOx sensors in previous Mastertech programs, including last month's release. The other input worth special mention is used on both 3.7 and 4.7-liter engines. It's the throttle position sensor, or TPS. This TPS is a new type that uses a Hall effect sensor instead of a variable resistor. Also be aware that the wiring has changed. The ground wire is now in the middle of the connector, so be sure to see the service information for wire identification and testing procedures. Both the 3.7 and 4.7-liter engines use their inputs to provide a low idle speed strategy. When these engines are coupled to an automatic transmission, under certain conditions, idle speed will decrease to around 500 RPM. There is also an output which has been implemented in all Chrysler, Dodge, and Jeep vehicles, which concerns the malfunction indicator lamp illumination. After the bulb check, a mill that flashes when the key is on but the engine is not running indicates that the vehicle is not ready for emission testing, since not all of the OBD2 monitors have been run at least once. The powertrain control module, which receives the inputs and actuates the outputs we've been discussing, is located in the right rear corner of the engine compartment next to the transmission control module. The exhaust systems on the new Ram pickup have a few features worth noting. For easier service, 3.7-liter engines use V-band clamps at exhaust manifold connections. Trucks built to meet federal emissions requirements feature one underfloor catalyst with an oxygen sensor before and after the catalyst. Trucks built to meet California emissions requirements have 2 close-coupled and 1 underfloor catalytic converter with the oxygen sensors before and after the close-coupled catalysts. That's about it for engines and engine systems. Before we move on to transmissions and transfer cases, here's a Dodge truck retrospective, a brief look at some Dodge truck history. The first Dodge truck sold to the public was actually referred to as a commercial car. It debuted as a 1918 model in the fall of 1917. Power was provided by a 212 cubic inch 4-cylinder engine that produced 35 horsepower. That's 3.5 liters of displacement for you metric types. Just as with engines, many of the features of the transmissions used with the new Ram pickup may be familiar to you. Let's start with available automatics. The 45 RFE multi-speed transmission is used behind the 3.7-liter and 4.7-liter engines. It's been in use on the Dakota and Durango, as well as the Jeep Grand Cherokee. For optimum performance, the 45 RFE control system provides overdrive lockup at a lower fluid temperature and the use of a map input to prevent hunting for the correct gear when the truck is driven on grades. Previous Mastertech programs have discussed the 45 RFE, so be sure to see this month's tech news for these and other releases related to the new Ram pickup. The 46RE automatic transmission continues to be used behind the 5.9-liter engine and is mainly carryover from the previous model year. Both the 45 RFE and 46RE use ATF Plus 4, otherwise known as Type MS9602 transmission fluid. Now, as we saw earlier, the transmission fluid coolers are oil to air and are not located in the radiator tank. There are a few things you should know about the differences between the transcooler used with the 45 RFE and the one used with the 46RE. On the 46RE equipped trucks, a bypass routes fluid through a different path in the cooler in cold temperatures. 45 RFE equipped vehicles do not need a bypass in the cooler. Because of these differences, the flushing procedure is different. One more feature of the automatic transmissions used in the new Ram pickup is located under the steering column. Both transmissions now use a solenoid-operated brake transmission shift interlock that prevents the operator from moving the gear selector out of park unless the brake pedal is depressed. The manual transmission used behind the 3.7, 4.7, and 5.9 liter engines is the NV3500. This transmission is mainly carryover from previous model years. Four-wheel drive DRs use either a manual or an electronically controlled transfer case. Both provide part-time four-wheel drive. The manual shift transfer case is the NV241, an all-new unit. There are a number of differences between this transfer case and the previous NV241. For example, a front axle disconnect is no longer used, and there is no synchro for four-wheel drive high. Be sure to see the service information for specific procedures for this or for the other new transfer case used with Ram pickup, the NV243. The new NV243 is similar to the new NV241 manual case, except that it uses an electronic control system to perform shifts. This control system is similar to the NV233 and the NV244 transfer cases in Dakota and Durango we told you about in the December 2000 bonus program. Electronically controlled transfer cases use a control module and selector switch located inside the cab, along with a mode sensor and motor on the transfer case to provide shifts. There's also a service four-wheel drive indicator located in the instrument cluster, which illuminates when a fault is detected in the control system. The transfer case control module communicates over the bus network, and you can use the DRB3 to read trouble codes, as well as for selector switch positions and mode sensor readouts. The use of an independent front suspension on four-wheel drive models was among the changes aimed at improving the ride and handling of the new Ram pickup. To accommodate that suspension, the Ram uses a C205F front axle, similar to the one in use on Dakota and Durango. You'll find that servicing the new front axle on Ram truck is similar to servicing the Dakota and Durango front axle. However, there are some new special tools you'll need to know about. These include new front and rear pinion bearing cone installers, special tools 8693 and 8692, a front pinion bearing cup remover, 8831, a pinion seal installer, 8695, and an axle seal installer, 8694. To transmit power to the rear axle, the new Ram pickup uses a rear propeller shaft similar to the one used on previous models. The corporate 9 1/4 rear axle is also mainly carryover. Next, we're going to move on to chassis components, but first, here's another piece of Dodge truck history. One of the most famous of all four-wheel drive trucks was the Dodge Power Wagon. The Power Wagon was based on the 3/4 ton military 4x4, which saw extensive use during World War II. The civilian version was produced from 1946 until the late 60s. The Power Wagon was known for its ruggedness and versatility. Many of these trucks were modified to be school buses, tankers, ambulances, and fire trucks. The frames under the new Ram pickup are all new. The side rails are manufactured using hydroforming, and each side of the frame consists of fully boxed front, center, and rear rails. Variations in center rail length provide frames for different applications. Besides providing a stiffer frame, the new process better accommodates cross-member attachment, since fewer welds are required on the frame rails during assembly. Underneath four-wheel drive models, another change is the use of a composite material instead of steel skid plates for the transfer case and front axle. On the new Ram pickup, both two-wheel drive and four-wheel drive front suspensions are all new. Two-wheel drive trucks continue to use short and long arms with coil springs, shock absorbers, and a stabilizer bar. However, now the upper control arms and the steering knuckles are made of aluminum. Upper ball joints are integral to the upper control arms and are not serviceable separately. As mentioned earlier, four-wheel drive trucks now use an independent front suspension. In addition to short and long arms, the four-wheel drive suspension has torsion bars and shock absorbers. Just as with the two-wheel drive suspension, the upper control arms and steering knuckles are aluminum, and the upper ball joints are integral to the upper control arms. The four-wheel drive suspension also uses a stabilizer bar. Some of the service features of these new suspensions are unchanged. However, others are new. For example, lower and upper ball joints continue to be lubed for life. There are no grease fittings. And on both two-wheel drive and four-wheel drive front suspensions, setting caster and camber still involves changing the position of the upper control arm. However, notice that these suspensions do not use a pivot bar for these adjustments. You need to loosen and move the control arm. On four-wheel drive front suspensions, ride height adjustment is similar to that on Dakota and Durango four-wheel drive trucks. If necessary, you can adjust ride height at the torsion bar anchors. There are a few more things you should keep in mind if you need to service these front suspensions. As mentioned earlier, the upper ball joint is part of the upper control arm and is not serviceable separately. However, the lower ball joint can be replaced separately from the lower control arm. There are a number of new essential special tools you'll need when working on the new front suspensions. They include a tie rod and ball joint puller, Special Tool 8677, a bushing remover and installer, Special Tool 8682, a torsion bar load and unload tool, Special Tool 8686, and a ball joint driver and receiver, Special Tool 8698. In the area of steering, the biggest change on the new Ram pickup is the use of a rack and pinion steering gear, replacing the recirculating ball type used previously. The power steering system now uses ATF Plus 4, otherwise known as MS9602. The power steering pump uses a composite pulley that is not reusable. You'll need to use Special Tool 8832 to remove an old pulley and 8833 to install a new one. The steering column on the 2002 Ram pickup is also new. It uses a new rotary tilt device. The tilt mechanism is not serviceable separately from the column. However, a number of other components are. These include the multifunction switch, ignition switch, gear shift lever, and overdrive switch. In the area of brakes, the new Ram truck continues the improvements made in previous model years. For the 2002 model year, the 1500 series pickup now has four-wheel disc brakes as standard equipment, a change made previously to 2500 and 3500 series trucks. The new Ram pickup brake system also has a new brake booster with improved performance. And because the air intake has been relocated to the engine compartment, the new booster also provides quieter operation. Along with the changes to the brake booster has come a change to the way it attaches to the master cylinder. Bolts now run through both the booster housing and master cylinder. And speaking of the master cylinder, you'll find that it's now larger and has a brake fluid level indicator switch in the reservoir. The last feature of the base brake system we need to look at involves the stop lamp switch. The switch now attaches to the steering column instead of to the pedal bracket. As before, the switch is not reusable once it has fully retracted. In other words, anytime you service the pedals or the column, you will need to replace the switch. In the area of anti-lock braking systems, rear wheel anti-lock continues as standard equipment on the Ram pickup. Although the basic system is the same, there have been a few refinements. R-Wall uses a new controller that incorporates the system solenoids. It is flash programmable. The controller plugs into the hydraulic control unit and can be serviced separately. However, whenever handling controllers, take care not to touch the circuit board or electrostatic damage could result. The brake fluid level switch described earlier is now an input to the controller. The biggest change to the R-Wall system is the addition of electronic variable brake proportioning, or EVBP. With EVBP, the proportioning valve has been eliminated. EVBP is also used on new 1500 series DR Ram trucks with four-wheel anti-lock braking systems. This feature was previously introduced on 2500 and 3500 series pickups. Like R-Wall, four-wheel ABS now uses a new controller. The next topic we need to cover concerns body features of the new Ram pickup. Before we do that, however, here's another piece of Dodge truck history. We take such features as anti-lock brake systems for granted on today's trucks. At one time, however, trucks were not necessarily equipped with hydraulic brakes. Dodge began to equip all of its trucks with hydraulic brakes in 1929. In the case of the new Ram pickup, body exterior changes go beyond changes to the sheet metal. In many areas, there have been structural and design changes that have an effect on service. Let's start with bumpers. The front and rear bumpers on the new Ram pickup are different than what you've seen in the past. A step pad has been added to the front bumper to facilitate engine compartment access. It attaches to the bumper with tabs on the bottom side. There is now a cross member ahead of the rear bumper that serves as a Class 3 hitch. A Class 4 hitch is available using the same cross member. Wiring for a 4-way trailer connector is standard equipment. The 7-way trailer connector attaches to a plate positioned against the inboard side of the bumper. The tailgate on the new Ram truck has been redesigned to be lighter and stronger. On the inside of the tailgate, you'll find that there is now an access panel that facilitates servicing the tailgate hardware. Cargo lamp operation has also changed. It is now possible to turn on the cargo lamp without turning on the dome lamp. The front end of the new Ram pickup has been completely redesigned. Instead of a structural fender combining inner and outer panels, this truck starts with a hydroformed tubular framework that serves as a substructure for the front end sheet metal. The new Ram's front fenders consist of outer panels that bolt onto the tubular framework. In order to remove this fender, you'll need to remove the hood and the cowl panel. In the area of stationary glass, you'll notice changes to both the windshield and to the backlight. The windshield is larger in size, and because it uses different trim components, you'll find that there are different removal and installation procedures. The backlight vent glass now consists of a single piece suspended in the glass channel by means of a pin. You'll need to remove the upper run channel to remove the glass. The window latch is glued on and is not available as a separate component. There has been a big change to the door setup on new quad cab Dodge Rams. These trucks now feature a B-pillar for front door latching and rear door hinges. Like the front door, the rear door uses a latch with an integral door ajar switch. Hinges and door adjustments are basically the same. However, you need to be aware that the doors are designed to be overflush to the roof and windshield. On the inside of the doors, all switch modules are attached to snap-in bezels that can be removed easily without removing the trim panel. The trim panel itself is attached to the door with screws at the release handle and mirror, and with hooks that are molded into the panels. When removing the trim panel, be sure to lift up on the panel before pulling it away from the door. All door glass, including the rear on quad cab, uses cross-arm window regulators. Power window motors are serviceable separately from the regulators. Next, we're going to break for another look at the history of Dodge trucks. Then we'll move on to AC and climate control. The association of Dodge full-size pickups with the Ram symbol has a long history. The first use of a Ram hood ornament was on the redesigned 1933 models. Air conditioning is standard equipment on the new Ram truck, and a dual zone system is now standard on SLT Plus and available on other models. The dual zone controls allow different temperature settings for the left and right sides of the vehicle. Operation of the AC heater control head is similar to Dakota and Durango. The microprocessor calibrates its system for the truck cab using the VIN broadcast by the PCM. It also tells the PCM when climate control operation involves air conditioning. The PCM then controls condenser fan and compressor operation. Changes in climate control system operation have been accompanied by changes to components both under hood and inside the truck. Engine application determines which one of the two different compressors is used in a truck. Suction and discharge lines can be serviced separately. However, you do need to be aware of new types of seals used on the lines. One type is a 3 O-ring seal that is part of a spring lock coupling. Be sure to lube these seals with refrigerant oil during assembly. The other type uses an O-ring on the line as well as a flat area perpendicular to the line for sealing. The sealing surfaces are secured with a fastener. This type is referred to as dual axis. One thing you won't notice under hood are high and low pressure cutout switches. They've been replaced by a pressure transducer. Earlier we showed you that the condenser is no longer in front of the radiator, but instead is next to it and is cooled by an electric fan. Unlike other fans you may have seen, the condenser fan is not pulse width modulated. It is either fully on or off. The condenser, fan, and fan shroud can be serviced separately. The AC system orifice tube is still located in the liquid line between the condenser and evaporator. As before, it's replaced with the liquid line. The HVAC unit on the new Ram pickup incorporates a change you've probably seen on other vehicles. All of the actuators now use electric motors that are driven by the control head. There are no longer any vacuum actuators. To find out more about the use of electric actuators, be sure to see the October 2000 Mastertech program HVAC Update. Our final climate control item concerns air exhausters. They have been relocated from the doors to the back of the cab. That's about it for climate control. Our next area is body, interior, and electrical, right after a look back at Dodge truck history. Some of you may remember a climate control improvement related to the Dodge truck redesign of 1972. That year, the air conditioning was integrated into the truck's air distribution system. Like so many other components on the 2002 Ram pickup, the instrument panel assembly is all new. A tubular cross car beam which attaches to the floor and the cowl provides the instrument panel with support. Keep in mind that with the change in design, the IP pulls straight out for removal. It does not roll back. The components attached to the instrument panel have also changed. Here are a few features you should be aware of when servicing trim pieces and other IP-related items. The top cover is smaller now. It is retained by clips which you can disengage by pulling the rear edge up and then pulling the cover back. You'll need to remove the cover to service instrument panel mounted speakers. The left and right end caps are held in place by clips. The lower left bezel is held in place with 2 screws, clips on top, and hooks on the bottom. When servicing the center bezel, don't forget to remove the screw before attempting to disengage the clips. On some trucks, a switch bank attaches to the lower part of the center bezel. These switches can be serviced individually once you have detached the bezel. The body electrical system is another area of the new Ram pickup that is all new. But if you've worked on other Dodge vehicles, you may recognize some familiar features. The Dodge Ram uses the single-wire PCI data bus network for communication between modules, the same type of network used on Dakota and Durango and other Dodge vehicles. Bus communication is much more extensive than in the past. The PCI bus on the new Ram can have up to 14 modules on it. A diagnostic junction port, similar to those used on other vehicles, is located under the instrument panel. One other item related to vehicle communication is worth noting here. It involves changes in the data link connector. Changes in SAE requirements and in SCI communication lines have resulted in changes in pin assignments to the connector. So be sure to see the wiring information for the revised connector pinout. On the new Ram pickup, body electrical activity is organized around two modules or centers. The front control module, or FCM, is located in the integrated power module in the engine compartment. It works with the instrument cluster to provide many body electrical features. By now you may recognize this system as similar to the one used on minivans. Let's take a look at the main features of this type of system as it occurs on the Ram pickup. Now, as mentioned earlier, the front control module is part of the integrated power module, or IPM, in the engine compartment. The other part of the IPM is the power distribution center. On the new Ram, the power distribution center contains all of the vehicle fuses. There is no junction block inside the truck. Notice that an IOD fuse is now located in the PDC. In the up position, the fuse is disconnected from the circuit. Not all circuit protection devices in the IPM are fuses. High side drivers in the front control module have replaced some fuses, and the power distribution center also uses positive temperature coefficient, or PTC, devices to protect circuits. These are internal components, and if they fail, you'll need to replace the FCM or the PDC. The power distribution center can be separated from the IPM. There are 7 color-coded connectors that are secured to the PDC by means of levers. To a large degree, it's the job of the front control module to control devices outside the cab based on instructions it receives over the bus from the cluster. These devices include high and low beam headlamps, tail lamps, turn signals, park lamps, fog lamps, washer and wipers, and horn. The FCM also controls brake lamps except for the CHMSL, which is hardwired to the stop lamp switch. In addition, the FCM is responsible for preventing adjustable pedal operation under certain conditions, as well as collecting and broadcasting ambient temperature sense and coolant level data, and for the trailer tow relays. Now, because the FCM controls lamp functions electronically, it's able to provide such features as daytime running lamps, exterior lamp battery saver, and voltage regulation of lamps. The lamp system is designed so that in case of a bus communication malfunction, the headlamps and cluster illumination lamps default to on. In many cases, it should be easy to track down the cause of a malfunction in FCM-related items, since the front control module also incorporates self-diagnostics. Once again, because of electronic control, the system can detect such failures as shorts or opens in lamp circuits, and you can retrieve this information using the DRB3. Lamp outage information is also broadcast over the bus to the instrument cluster and electronic vehicle information center. The instrument cluster, which is the other hub of body electrical activity, actually combines the functions of a typical electromechanical instrument cluster with those of a body control module. The central timer module featured on BR models is not used on the DR. In addition to traditional instrument cluster features, the cluster controls instrument panel lamps, interior lighting, including fade and battery saver, vehicle theft alarm, power locks, chime, wipe control, heated seat module activation, brake transmission shift interlock, and remote keyless entry. The remote keyless entry module is attached to the cluster and works with it to provide RKE functions. It's serviceable separately. The cluster itself is flash programmable. Many of the inputs to the cluster come by way of switches hardwired to it, and many of these are multiplexed. These multiplexed switches include the headlamp and multifunction switches, power lock switches, and remote radio controls. Like the front control module, the cluster performs self-diagnostics and stores trouble codes when it detects a malfunction. You can read these trouble codes with the DRB3. You can also access some codes by initiating the cluster self-test and checking the odometer display. Earlier we said that the front control module and cluster work together to provide many body electrical features. Let's look at how this works with one of these features, headlamps. The multiplexed headlamp switch provides an input to the cluster requesting headlamps. At the same time, the multifunction switch input tells the cluster whether high or low beams are needed and whether it needs to turn on the high beam indicator. The cluster then sends a message over the PCI bus to the front control module requesting that the headlamps be turned on. The FCM does this by means of high side drivers. The FCM can also monitor the headlamp circuit for any signs of a malfunction and send a message back over the bus to the cluster requesting the lamp outage indicator be turned on if it sees a problem in the circuit. Beyond its role as a control module, the cluster itself has some features that are worth noting here. There are two vacuum fluorescent displays, the Prindle and the odometer. The engine hours readout in the odometer is new. To access the hours with the key on and the engine off, push and hold the trip button down until the display changes. The cluster self-test remains the same. If any of the 6 gauges is faulty, you'll need to replace the cluster. The cluster LEDs are also not serviceable separately. However, you can replace the incandescent cluster illumination lamps. On trucks with tilt columns, the cluster can be removed and installed without disturbing the column. If you do need to remove a non-tilt column to service a cluster, keep in mind that the bolt on the column intermediate connection is not reusable. Be sure to jot down the mileage and accumulated engine hours before removing the cluster, since you need to provide the repair center with this information. One change to audio systems on the new Ram pickup involves the premium sound system. Instead of using integral speaker amplifiers, the premium system is powered by a 240-watt digital audio amplifier located above the glove box. This amp communicates over the PCI bus and can be diagnosed using the DRB3. Another interior feature that is new to Ram pickup is the Electronic Vehicle Information Center, or EVIC. The EVIC includes Compass mini-trip computer functions and the HomeLink universal transmitter. It's similar to those in use on other Dodge vehicles. The PCI bus provides the EVIC with much of the information in its display. For example, it receives ambient temperature information from the front control module. The warnings displayed by the EVIC include a number of lamp outage messages that specify which lamp circuit needs to be checked. The EVIC also now provides an easy way for Ram pickup operators to program a long list of vehicle features, such as those involved in power lock, horn, and headlamp operation. The last body electrical feature we need to look at is power adjustable pedals. They are available with SLT and SLT Plus models that are equipped with an automatic transmission. A switch on the instrument panel to the left of the steering column operates the motor and the pedal assembly. The motor moves the pedals together on track rods to provide about 3 inches of travel. The pedal ratio also increases slightly as the pedals move toward the driver. The FCM uses a PDC relay to prevent power from reaching the power adjustable pedals if the transmission is in reverse or the speed control is set. You can access power adjustable pedal components by removing the knee blocker below the steering column. The motor and the cables which link it to the worm gears are serviced as an assembly. The final area we're going to look at on the new Ram pickup is passive restraint systems. First, however, let's take one last look at Dodge truck history. With the increasing use of trucks for personal transportation, we've come to expect the same interior features in trucks as in passenger cars. It wasn't always that way. In 1948, Dodge truck buyers had to opt for the top-of-the-line custom cab to get a driver's armrest and dome light. Passive restraints is another area where you'll find substantial differences between the new Ram pickup and the previous model. The new Ram uses next-generation single-stage driver and passenger airbags. Pre-tensioners on the driver and front passenger seatbelts enhance passive restraint performance. On the driver's side seatbelt retractor on standard cab models, there is also a unique tension reducer solenoid that actuates only when the driver's seatbelt is buckled and the ignition switch is on. Available side curtain airbags help protect vehicle occupants during side impacts. On quad cab pickups, this protection extends to rear seat occupants. Each side curtain airbag is controlled by a side impact airbag control module, or SIACM, located behind the B-pillar trim on its side of the vehicle. Each SIACM contains 2 accelerometers to sense side impact. A passenger airbag disable switch continues to be included with regular cab pickups. For further information about airbag system operation, diagnosis, and service, refer to the service information as well as to the May 2001 program Passive Restraint Systems Update, or to the Passive Restraint System course 0630108. Speaking of service, there are a few items worth noting before we leave passive restraints. First of all, the trim cover and horn switch may be replaced separately from the driver airbag. You'll need to drill out the rivets to separate the pieces. An undeployed passenger airbag can be serviced without IP removal. Both panel outlet housings on the passenger side of the instrument panel are removed with it. There are 2 sets of part numbers for side impact airbag control modules. The modules are used on the right and left sides of the truck and include unique mounting brackets for standard and for quad cab applications. Finally, note that should the side curtain airbag deploy, the headliner must be replaced as well. Well, that brings us to the end of this look at the new Ram pickup. Be sure to join us next month when we'll be looking at service highlights for the rest of the 2002 model lineup.